Good morning and welcome to today's talk on the entry, descent, and landing of the EDL and the Perseverance rover, nicknamed the 7 Minutes of Terror. My name's Lisa Hoover. I'll be your host this morning, and thank you for joining us. In the chat, give us a shout out. Tell us where you're watching us from. Our special guest today is Jose Santos, aerospace engineer and the Metley 2 deputy director and project manager from NASA Ames Research Center. Also joining me on the Chabot side is one of our Chabot experts, Gerald McKeegan. And first of all, just a quick congratulations on the success of yesterday's mission. That's fantastic. Before we go into our talk, to let you know just a little bit more about our guests. And by all means, if you have questions about the mission, put them in the chat. And after our talk, we'll try to answer as many as we can with the time that we have. So why don't we start with you, Joe McKeegan is a longtime volunteer of Chabot and an astronomer. He's part of our board of directors, and he's a key member of the East Bay Astronomical Society, which resides at Chabot. He has a Master of Science in Space Studies and over 40 years working in the space industry. He's been involved in numerous space projects, including some of the space shuttles, the Mars Reconnaissance Orbiter, Mars Insight, Solar B, Juno, and many more. In 1988, he was awarded the NASA Silver Snoopy Award from the NASA Astronaut Office for his work in the support of post-Challenger Space Shuttle Return to Flight program. He also conducts really important research on site at Chabot using our 36-inch telescope on asteroids. So welcome, Gerald. Now, our special guest today, Jose Santos, comes to us once again from the NASA Ames Research Center. He's an aerospace engineer in the Thermal Projection Materials branch at NASA's Research Center in Silicon Valley. His work focuses on the development, qualification, and the integration of aeroshell instrumentation for planetary entry vehicles. He is currently the Deputy Project Director of the Metley 2 project, which is a sensor suite that he'll talk about in his presentation just shortly. He supported several flight instrumentation projects, including the Artemis mission and the original Metley suite, which flew on the Mars Science Laboratory spacecraft back in 2012. He received his Bachelor of Science degree with a double major in mechanical and aeronautical engineering from UC Davis and a master's degree in aeronautics from Stanford University. So welcome, Jose. I will turn it over to you.
Thank you very much, Lisa. I'm very excited to be joining you all virtually today. I'd like to thank everyone involved in organizing and planning this event today. I know it takes a lot of effort and work to coordinate these types of events, so I very much appreciate your effort and for inviting me to speak to everyone. On behalf of NASA's Medley 2 team, I'd like to just thank everyone for joining us today. I have a very special presentation to share our contributions to NASA's Mars 2020 mission. As we all know, the Perseverance rover safely landed on the surface of Mars yesterday afternoon. It was just an absolutely thrilling event. I was able to share the experience with my Medley 2 colleagues, and we were able to receive data from the spacecraft as it was sent back to Earth to monitor the health of some of our sensors that we had on board the spacecraft that I'll talk about today. So all in all, yesterday was just a monumental day for NASA and for space exploration. Perseverance's journey started last July 2020, and it landed yesterday, so it took a little over 7 months for Perseverance to make the journey from Cape Canaveral in Florida to Jezreel Crater. And that distance is over 290 million miles. Can you imagine how far away that is? You would have to travel around the Earth about 10,000 times to travel the same distance that Perseverance did in order to make its way to Jezreel Crater. That's just an amazing accomplishment and something that's just very inspiring to be a part of. We do know that we can only launch to Mars every 2 years or so because of the way that Earth and Mars are in relation to each other as they orbit around the sun. So we had our window this past July, and we did have our challenges with the COVID-19 pandemic. Everybody on the Mars 2020 project did an outstanding job to overcome the adversity and make the adjustments to keep the launch date and successfully launch Perseverance on its way to Mars. The EDL team at JPL, which you might have seen on NASA TV yesterday, did a tremendous job designing and implementing, building, and executing the EDL phase of the mission, which consists of several systems that I will talk about today as well in the video that you'll see coming up shortly. First off, I just would like to describe the focus of my presentation, and then we can jump into the video and a couple of very cool photos I would like to share with everyone. So I have worked on a project called Medley 2, which stands for Mars Entry, Descent, and Landing Instrumentation number 2. Now, for the past 6 years, I have dedicated much of my time to developing devices called sensors that will measure, or that did measure, the environment that the spacecraft flew through the Martian atmosphere prior to safely landing on the surface. Perseverance was the heaviest and most technologically advanced rover they have ever sent to Mars. Success is never guaranteed. EDL is such a difficult part of a mission that we call it the 7 minutes of terror. And you'll see coming up in the video why that is. It's just such a terrifying experience, and everybody's on the edge of their seat as the spacecraft begins the entry maneuver. And the reason is the spacecraft has to do all of that on its own. We program it and we teach it to be able to safely land at a destination site within a certain region. We call it a landing ellipse. And it has to use its onboard technology to safely land on the surface while diverting away from obstacles and harsh terrain. And the onboard computer decides the best way and the safest location for it to land. So all of that is just an amazing accomplishment, and I could not be more proud of the NASA family for this tremendous accomplishment. Now I think we can jump to the video. I believe Lisa will help me with this portion. As the video plays, I will provide some commentary of what you'll see. You can go to full screen. What you're seeing now is in deep space. The configuration of the spacecraft is what we call cruise stage. So the rover is inside a protective shell called the aeroshell. And that aeroshell is attached to a cruise stage that is used for the journey from Earth to Mars. It's coming right at us right now. What you're seeing is the brown colored heat shield. And there you go. It released the cruise stage, and now we just have the spacecraft. It's about to enter the Mars atmosphere. You see some of the thrusters firing there in the back cover that's painted white. Now it's flying through the Martian atmosphere at a speed of about 12,000 miles per hour. And as it does so, it encounters a very intense heating environment because of the very high speeds, and the flow has to move its way around the spacecraft. And as it does so, the temperatures on the surface can get supremely hot. One Once it safely passes through the atmosphere, it deploys the parachute that you see in the video to decelerate to a slower speed. However, the parachute cannot fully prevent the vehicle from an excessive speed prior to touchdown. And so what we do is we have a sky crane system, which consists of rockets to further reduce the speed of the spacecraft. And that's what you're seeing now. The Curiosity rover is using its onboard technology to capture images of the ground on Mars and compare it to its data. And once it figures out where Perseverance is, then she decides to select the safest and the most efficient place to land in. She does so by lowering the rover on cables. Once the rover has accomplished touchdown, then the sky crane safely flies away and Perseverance is successfully landed on the surface of Mars. I could never watch this video too many times. It's just very inspiring and just very, very tremendous to look at. I believe that's the end of the video. I would like to go back to around the 50-second mark. Here we go. Okay, if we can pause here. Oh, can scroll back a little bit more. Scroll a little bit until we see, there we go, and press pause here. Okay, so you see the bright colors there in front of the spacecraft, and it has a front cover that we call the heat shield and a back cover called the back shell. And this is the material that protects Perseverance from the extreme environment that I talked about. The front surface of that heat shield can reach temperatures on the order of 2,700 to over 3,000 degrees Fahrenheit. That is comparable to the surface of the sun, which we know is around 10,000 degrees Fahrenheit. So it's about a third of the temperature on the surface of the sun. And so this is just an extreme amount of heating that we have to protect Perseverance in order for her to safely deploy the parachute. And you might be wondering, how do we know all of this information? How do we know how hot the spacecraft gets as it flies through the atmosphere? And that's where a team of NASA engineers and scientists who specialize in entry, descent, and landing come into play, such as myself. I specifically work on sensors that are installed inside the heat shield material, as well as on the back shell cover. These sensors measure temperature and pressure, and also they make a direct measurement of heat flux. So we know, for example, that a thermometer can measure the temperature of your room. So in a way, a thermometer is just a type of sensor. And so when I describe a temperature sensor for this spacecraft, we use a special device called a thermocouple. And this is what we use to measure temperatures through the thickness of that heat shield material. Okay, now I think is a good time to transition over to the pretty cool photos that I have prepared for you today. If we can go to the beginning. I couldn't begin without showing this awesome image of the JPL team in mission control celebrating once they received confirmation of touchdown by the Perseverance rover. I did mention that the rover traveled 290 million miles, and what that means is the communication signal also has to travel that same distance. And we know that the speed of light takes around 11 minutes or so to one way to reach the Mars from Earth. And so it'll be another 11 minutes from Mars back to Earth. So in reality, Perseverance would have landed by the time that we received confirmation of a safe touchdown. I just wanted to share this image of the JPL team celebrating the amazing accomplishment. In the photo there, you see lots of the folks involved with the Mars 2020 mission. We have the Mars 2020 project manager, a lot of folks from NASA headquarters as well. So just all in all, yesterday was a very successful day and a good day at Mars, we like to say. Next chart, please. Okay, so the rest of this talk, I will focus on my contribution to the mission. As I described, the project is called Medley 2. Aeroshell, the word aeroshell, it just means it's the assembly that consists of the heat shield that you see in the background there. That's the brown to yellowish to green colored dish that you see in the background. The back shell is the cover that's painted white in the front and center in the image. You also see two people there working on this hardware. So this gives you a sense of the size of each one of these components. The person in the background there is standing on the edge, close to the edge of the heat shield, and he looks like a pretty tall person, right? But yeah, he doesn't even reach half of the size of that heat shield. So it gives you an idea just how big of a structure we have to build, and just all of the engineering and the planning and the design work that goes into building such a tremendous object like the heat shield and the back shell. You also see some labels in the image in the white text. Those callouts are the specific sensors that are part of the Medley 2 system. There are 3 categories of sensors. The first is called an instrumented thermal plug. Those are responsible for measuring temperature. We also have pressure transducers. These measure the pressure that's felt by the vehicle as it's flying through the atmosphere. You can think of pressure as a force acting over a specific area. So, for example, if you ever know anyone who has gone to the doctor's office and they measure their blood pressure, they wrap around this piece of Velcro around their arm, and then they turn on the machine. Then you hear the machine making noises, and then that thing they wrapped around their arm starts to apply pressure in order to make the blood pressure measurement. It's a similar concept here where the flow of gas around the vehicle is applying pressure on the surface. And as engineers and scientists, we're interested in measuring that quantity and to know it with certainty so that we can go back and verify our design and compare to our computer models. The third category of sensors on Medley 2 is called a heat flux sensor. These are devices that make a direct measurement of heat flux on the back shell. So we have different kinds of heat flux. One is what we call convective. That's direct transfer of heat from the flow of gas to the surface of the back shell. Another is called radiative, and that's radiation is what you would feel from the sun when you're outside on a sunny day. That's the warmth that you feel, and our sensors are capable of measuring the amount of radiation that makes its way to the surface of the back shell. We use that information to gain knowledge about how well the material performs and protects the rover. You have to remember the rover is tucked away safely inside the heat shield in the back shell. And so it just takes years and years of work to design and make these structures. This facility here is actually in Denver. Medley 2 was implemented through a collaboration with 2 NASA centers. One is in Virginia at NASA Langley Research Center, and the other is where I work at Ames Research Center here in Silicon Valley, just a short drive from the Chabot Space and Science Center. And then we also partnered with Jet Propulsion Laboratory in Pasadena. They were the main, you can say, organizer of the Mars 2020 mission. And we also collaborated with Lockheed Martin Space Company, who did a lot of the hands-on work and built the aeroshell and delivered it to NASA. So as you can imagine, there's a lot of teamwork and group work involved. If you were to ask me, what skill can you work on and begin developing now while you're still in the early part of your academic career? I imagine there are students from elementary school and also middle school, perhaps high school. Now, one key skill that you can work on now is group work and teamwork, as well as your communication skills. We cannot emphasize enough the importance of having clear communication among team members and working together towards a common goal. And then later on, of course, you can begin taking your science and physics classes and courses in mathematics. All of that comes together towards a successful mission. Next chart, please. So now I'd like to take you behind the scenes and give you kind of a peek at what goes towards installing the Medley 2 sensors on the heat shield and back shell of the Mars 2020 vehicle. What you're seeing here may resemble some kind of a science project or an art project, perhaps. You can see a paintbrush. There's this bright colored orange tape. There's also some green tape, and then maybe some brown colored paper underneath that's protecting and masking off the heat shield material. And there's also some pieces of red adhesive far off there in the background. What you're seeing is a person installing one of the instrumented thermal plugs. These are the ones that measure temperature. And so you might ask yourself, how do we install these thermocouples into the heat shield? And the way that we have devised is to actually drill out a hole in the heat shield that you see there towards the bottom middle of the image. And we drill out this hole that gives us room to install our sensors. And we fill the hole with a cylindrical piece of material that's the same material as the heat shield. And we need this cylinder to stay in place. So one way to do that is to glue it essentially to the heat shield. And we do that using a special kind of adhesive that you see there that's red in color. We apply that adhesive with the paintbrush tool that you see. Very generously, we apply the adhesive and then we feed the electrical wires through those tubes that you see sticking up above the surface. We feed the wires to the other side of the heat shield and then we push down onto the plug so that remains at the same height as the rest of the heat shield. So this gives you an idea of how we install our instrumented thermocouple plugs. It's quite a sight to see in person. I was very fortunate to be able to witness this process for all of the Medley 2 instrumented thermocouple plugs. This occurred last year, or actually in 2019 in the summer timeframe. So even though it was nearly a year and a half or so ago, I still remember it as if it was just yesterday. All of this work is very impactful and it gives us it adds new meaning to all of the hard work that we have to put into a project like Medley 2 and Mars 2020. Next page, please. Okay, here's another cool photo. This time what you're seeing is the heat shield actually in a configuration where it's nose down. So the apex or the pointy part of the heat shield is nearly touching the ground, but it's actually supported by the structure that you see there that's painted white. And there are two people in the photo. If you can try to look closely, there's one person in the bottom right corner there. You can see his arm. He's laying down on the floor and holding what looks like to be a lamp. He's actually applying this heat lamp to one of our instrumented thermal plugs that I just described in the previous slide. If you look closely where the bright orange spot is, there's a red circle, and that's one of our plugs that has the temperature sensors in it. And then towards the bottom left corner of the photo, there's another person holding what looks to be some kind of a measurement device, and it has this gray housing to it. This device is pointed at the bright spot to be able to measure the temperature. And what we're doing here is doing a functional check to make sure that the sensor is still working properly and how we expect it to be working. The heat lamp actually heats the surface of the heat shield to a reasonable temperature. And we don't want to go too high because the main job of the heat shield is to protect it during entry. So we want to be very careful with it. This is before the heat shield is integrated with the rest of the Mars 2020 hardware. So we are doing functional checks to make sure that our sensors are working properly. And we do these kinds of checks along the way to make sure that we can have the greatest chance of success because we are counting on these sensors to provide us this great data to compare to our computer models and understand the environment that the vehicle flew through the atmosphere. And also, not only that, but it also helps future missions to Mars because we can improve our computer models and come up with even better designs for the next mission. Some of you may know that the next mission is the part of the Mars Sample Return Campaign. That's a campaign designed to bring back samples from Mars back to Earth. And there are various elements to it. And the Perseverance mission was the first step. So we're all very happy that Perseverance is ready to go off and do great science and actually core out these samples. And I'm also just very thrilled to be a part of all of this work that NASA is involved in. Next page. This photo here may look strange, but actually this is what you would see if you're looking from the other side of the heat shield on the back side. The black color you see there is actually part of the structure. You see some bolts there that put everything together. You also see these cables that are wrapped around in orange tape. That's a special material that is part of the bundle to hold all of the wires together. They're clipped down to make sure they stay in place during the journey to Mars and during the entry. And what I would like to call your attention to is the copper-colored circle towards the center of the photo. You can see one of the orange cables connecting that orange circle there to another cable that goes off to our data system. But that orange piece, the copper-colored piece in the center of the image, has 3 bolts that attach it to the heat shield structure. And this is actually one of the heat flux sensors that I talked about, which measures the heating environment at the surface. The other side of this heat flux sensor is on the face of the back shell protective material. And so it's directly measuring the heating from the hot gas and also from the radiation that occurs during the entry. Next chart. This is a pretty awesome photo as well. Here you see the heat shield in a nose down configuration. The back shell's in the background there, and they're multiple people wearing their special bunny suits, we like to call them. It's clean room attire because this room here has to be maintained at a certain cleanliness level because this is space flight hardware. And so you can see there on the heat shield all of the cabling that's part of the Medley 2 harnessing system. And it seems to be going every which way. It's kind of like a maze, but that's actually on purpose because we want to avoid other parts of the hardware that'll take up some of that room when the heat shield gets mated to the back shell and later integrated into the rest of the launch vehicle system. So all of this work entails multiple fields of study. There's engineers who have to figure out how to route and design this cabling. You have folks who have to schedule and plan out the project from the beginning all the way to touchdown, and then as well as the surface operations team, once the rover touches down, they have to plan out all of the activities that the Perseverance rover will perform during its time on Mars. So this kind of gives you an idea of all the hard work that goes into making an aeroshell and installing the Magic 2 system. Next page. This is another pretty cool and pretty special photo. What you're seeing here is from the underside of the back shell cover. The rover is tucked away inside that back shell cover. The wheels are protected using those pieces of the white material that you see there. Then if you look closely, there's a blue circle there that's semi-transparent, and that's pointing out a special commemorative plate dedicated to all of the healthcare and essential workers that are key that were key to keeping us safe during the COVID-19 pandemic. I think this was a special touch on the part of NASA to provide this commemorative plate to them to recognize their daily efforts to keeping everybody safe and healthy, and also just to acknowledge the adversity and the challenges that we've had to overcome to put this spacecraft together and successfully launch it to Mars. This was a nice touch. Next page, please. So here is a zoomed out view where you see all of the various pieces start to come together. The heat shield is still nose down. We are now actually at Kennedy Space Center in Florida. Towards the middle, you have the back shell with the rover safely tucked away. Then attached to the back shell is the cruise stage. This is the cruise configuration that I talked about, which is mostly used for the journey from Earth to Mars. So all of this has to come together, kind of like a jigsaw puzzle being connected to each other. So everything is well documented. Everybody has to think about the best way to put everything together. We document all of that in our drawings. We have mechanical engineers who actually come up with 3D computer models of all of this hardware in order to make sure that everything fits nicely together. And this is just an awesome photo to look at. Next page. Here is a spacecraft with the heat shield and the back shell connected together. The rover is now inside, and the cruise stage is just about to be attached as well. This would now be taken over to a different facility for integration onto the launch vehicle. All of this takes months to occur. It doesn't happen overnight. It takes a lot of planning and just a lot of hard work by all of our NASA family. I think that was the last image. We can transition over to questions and answers, I believe.
Thank you so much, Jose. That was incredible. I've learned so much about the mission. So I have to know that that very moment when you got the word that it was a success, how was it for you?
It was truly amazing. This time we all had to celebrate virtually. The JPL team there was obviously in the mission control room. The Medley 2 team was supporting virtually each of us from our respective homes. And we were watching it on NASA TV just like everyone else. And we were kind of on the edge of our seats, very anxious to hear the words being of touchdown to be pronounced. So it was just exhilarating. And I celebrated with my family. My wife and daughter were just thrilled as well. And we also had a kind of a video chat with other Medley team members, and everybody was just super happy that it was a fantastic day.
Fantastic. And I see you're wearing your Medley 2 patch. Congratulations.
Yes.
I know there's lots of patches for each division. That's fantastic. So
Yes.
we have our first question from Facebook here. Um, Kishore asks from India, um, why was the landing called the 7 minutes of terror? Is the first question.
That's an excellent question. The 7 minutes of terror refers to the time that it takes for the spacecraft to go from the point that we call entry interface. This is a point where we define to be the beginning of the Martian atmosphere. And then it takes 7 minutes to go from there all the way to the surface of Mars. And it's terrifying, we call it, because the spacecraft has to do that, has to perform this maneuver all on its own. Remember, I talked about the 11 minutes or so that it takes communication to travel one way from Earth to Mars, and then another 11 minutes to go from Mars to Earth. So we know that it takes 7 minutes to for the EDL maneuver to be performed and safely land. So there's no way for us to command the spacecraft to do what we would like it to do in order for it to accomplish the landing, because it would just take too long. And by the time we received confirmation, it had already performed all of its maneuvers and was already on the surface of Mars. And we call it 7 minutes of terror because in a way we're helpless, right? We double check and triple check all of our lines of software code. But EDL is just such a difficult phase of the mission that you just never know. Success is never guaranteed. Many nations have attempted to place a rover on Mars. Some have been successful. Others have experienced failures, including NASA has experienced one failure. And so it's just a very difficult thing to do. And because we're helpless, we call it the 7 minutes of terror.
Terrifying indeed. The next part of their question is, why was it important to target or land at Jezreel Crater?
It's another excellent question. We know that Curiosity landed at a different place in Mars, and Jezreel Crater was determined by NASA's scientists to be very favorable for us to study. If you look at some of the images that were shown on NASA TV, you can see that there are signs of an ancient lake bed and a potential river delta. So we're interested in knowing whether life existed on Mars, past or present. We know that presently the climate and the environment on Mars is very harsh, and so it's very unlikely that life could survive on the surface of Mars in the present day. But several billions of years ago, it's possible that life could have existed, potentially in the form of single cell organisms or other microbial life forms, not perhaps in as like people like you and me or you and I, but more like on a very smaller scale. And we like to say that we follow the water. So that just means that here on Earth, we know that we need water to sustain life. We all need water to stay alive. And so that's the only thing we know. And so we tried to look for signs of water on Mars. We have discovered presence of water in the frozen state, subsurface, and also on the northern polar ice cap. And so scientists determined that Jezreel was a pretty good spot to go off and explore for what we like to call biosignatures or potential signs of life.
That's great. So, Gerald, you've been quiet all this time. What
Yeah,
questions
I'm
you
trying
might
to
have?
get an image up here showing Jezreel Crater.
You did. We saw it.
Yeah, and
Yes.
to give you an idea what we're talking about here, let me get that back up again here. Uh, Jezreel Crater, 3.5 billion years ago, was a lake. It is an impact crater, but it then filled with water, and that water came from a river. And so in this image, you can see the river channel here flowing into the crater. So this is Jezreel Crater here. This is the river. It cuts through the rim of the crater here. And as it emptied into the lake, it created this delta region that you see here. This is all sediment and debris and silt and so on that flowed down the river into the lake. And so this was considered by NASA to be a very good spot to look for potentially, fossilized remnants of past Martian life or organic materials or things that represented the possibility that life once existed on Mars. So that was why Jezreel Crater was chosen.
That's great. All right, folks who are watching us out there, what other questions might you have for our guests this morning?
I saw another question, Lisa. Someone asked if the rover has started walking yet, and actually it rolls, but it doesn't walk. But it has not started moving yet. It is right now stationary. They are doing some testing. They've sent down some initial imagery with the has cams, which are cameras kind of down below the body of it, pointing forward to spot hazards as the rover is moving along. But those cameras are already working and already sending images. There's also been some great images from the Mars Reconnaissance Orbiter. You can actually see the jet or the rover descending down on the parachute. So I was
Yeah, I
wondering.
would.
Go ahead, Jose.
Oh, I'm sorry. I was just going to say that I would be interested if there are any images of the heat shield being jettisoned. Actually, back in 2012 for the Mars Science Laboratory mission, there was an image captured of the heat shield being jettisoned, and you could actually see some of the wiring corresponding to the original Medley flight system. So that was awesome to see as well. And I know that this time around for Perseverance, there's much more technology on board, including cameras to look at the parachute as it was descending onto the surface. And there are also microphones on board to hear for the first time what Mars sounds like. It might be eerie, or I don't know what to expect, but it catches my imagination as well just to hear sounds on Mars. It's pretty amazing.
Yeah, they're bringing down a lot of images. And I know there's one already that was taken showing the rover as it was being lowered from the sky crane. And I suspect there's a lot more going to be coming down here over the next day or two, including images showing the ejection of the heat shield and so forth. So, yeah, that'll be exciting to see that. I've been kind of monitoring the Mars 2020 image gallery, and, things are popping up as we go along. And that's one of the
Mhm.
great things about these missions is NASA shares everything, and so you get a chance to see a lot of this as almost as it's happening.
Yes.
That's great. So we have another question from our audience on Facebook. The question is there danger of contaminating Mars with bacteria that might be on the equipment from Earth? Is the equipment sterile?
That's a great question. NASA has folks who work on what's called planetary protection and contamination control. And their job is to ensure that the hardware we send from Earth to Mars is very clean, such that we don't contaminate, Mars with any of our organisms from Earth, and then because that could potentially, lead to any confusion if we bring stuff from Earth onto Mars, and then when we bring it back, then we want to ensure that whatever we bring back from Mars is truly from Mars. And the job of the contamination control and planetary protection folks is to make sure that that is the case. I mentioned the Mars sample return mission that is next up for NASA. I think on NASA TV, they mentioned yesterday that the containers on board Perseverance, which will be responsible for holding the samples that the rover cores out of the Martian soil, those are the cleanest containers that we have ever made on Earth. So it just shows you just how much attention we pay to having everything super clean to ensure that we do not have any contamination from Earth.
Great. We have a comment from Bridget on Facebook. The comment is really impressive video footage. Who's responsible for making it and how?
I believe Bridget might be referring to the video that we showed earlier. If that's the case, that video, if you'd like to view it again, is publicly available on YouTube, and it's posted on the NASA Jet Propulsion Laboratory channel. And they have folks there who make such animations for us to visualize and imagine, the trajectory of the spacecraft. And so they take input from scientists and engineers to make it as accurate as possible. You might have also seen a simulation on NASA TV yesterday where they showed in real time each event from the EDL phase of the mission. That is also available on the website. It's eyes.nasa.gov. There's an animation there that you can also see. So all of the video and special effects folks are the ones who put that together.
That's great. And as well as still images, I imagine a lot of artists must work for NASA, which is not always something that people think about in terms of roles.
That's right. Everybody has a key contribution to make, and we do need artists as well, as you mentioned, Lisa. Some people have limited drawing skills, like myself, and so we rely on computers to make these images. And some folks are very good at imagining, what a logo should look like, or what a spacecraft should look like. And so we have just multiple disciplines at NASA.
That's great. Speaking of roles and careers, how did you get started with NASA?
I think my path is very similar to other folks in the sense that from very early on, I dreamed of working for NASA. I always enjoyed math and science in elementary school and in junior high as well. I remember having to study the times tables when I was in first or second grade, and that just kind of propelled me towards a career in STEM, which is science, technology, engineering, and mathematics. And I'd like to encourage everybody watching today to consider a career in STEM. So after knowing that I wanted to work for NASA one day, I just pursued a career in engineering. When I was in high school, I researched possible majors in a field to study. I went through the various types of engineering, and the one that appealed to me the most was aerospace and mechanical engineering. I actually did a double major in college at UC Davis. One was in mechanical engineering, another in aerospace. I think because mostly at the time I couldn't decide between one or the other, and said I wanted to study both. And then after that, I knew that I wanted to uh, become involved somehow with NASA's mission. And so I ended up applying for an internship and was fortunate enough to be accepted to an internship. After the internship, I stayed on full time as an employee there. And I think the thing that helped me the most to acquire an internship is just communication skills and also ability to work in teams, as well as having exposure to different kinds of fields, and having working on projects outside of school that are that align with your interest. And I think that's just look for areas to kind of stand out from the crowd, so to speak, so you have as broad a knowledge in multiple fields as possible. And from there, just aim for the stars.
That's inspiring. Um, so, Jose, what's next for the Metley 2 team? Are you already working on your next mission?
Actually, the work for us is continuing on. You could say we're in the next phase of the project, because now that we received some of our data back here on Earth, we have a small data set that we're starting to review and trying to understand how our sensors performed during the entry. The rover has not yet sent back the full data set, which contains all of the sensor channels, but our plan is to use the data that's sent back to compare with our computer models. So, for example, we have temperatures that are measured in the heat shield, and we have a computer model that predicts how hot the heat shield should have gotten during the entry. We make the comparison between the data and the computer model and try to figure out the reasons for any possible differences between the two. And so you can imagine the amount of work that is still left to be done. We know that the scientific community is also interested in this data. Everyone in the EDL community kind of considers this kind of data to be very precious because it's a bit scarce. Up until Mars Science Laboratory, not very many missions contained instrumentation or sensors on the heat shield and back shell of a spacecraft. And starting with Mars Science Laboratory, we've been able to include this instrumentation. It's helped us out tremendously. So yes, we will continue to look through the data, await the full data set, and then in the next couple of weeks and months, we'll perform the analysis and publish a few papers so that we can share the results with the rest of the community.
Well, we're looking forward to learning more about those discoveries. Well,
Okay.
we're just, go ahead, Joe.
Yeah, I wanted to ask a technical question. You mentioned modeling the temperature at the heat shield versus what you actually measured. Um, does the temperature is it highest right at the surface of the heat shield, or is the temperature actually highest a little bit away from the heat shield? Is there a boundary layer between the hottest part and the heat shield itself?
Yes, so the hottest part is at the surface of the heat shield material that's directly exposed to the hot gas flow around it. And then there is what we call a gradient through the thickness of the heat shield material. You can think of it as the material being the hottest at the surface, and then it progressively, that heat energy progresses through the thickness of the material. And so it would be the coolest at the point where the heat shield material attaches to the substructure of the aeroshell. We want to be very conscious of that temperature at the point where the heat shield material is bonded onto the structure, because we do not want it to get too hot. Otherwise, that could pose a potential danger to the spacecraft. the job of the heat shield is to protect it from that extreme environment. So by design, the material is intended to keep it that interface at the point where the material transitions to the substructure. We want that place to be the coolest and to not exceed a certain threshold temperature so that the heat shield material does its job. That's part of the reason for having sensors embedded inside that cylinder of material that I showed earlier. We have these temperature devices called thermocouples at various depths from the surface. That way we can get an idea of how much of the energy has been conducted through the material, and we can get an idea of the curve, so to speak, of temperature being the hottest at the surface and then progressing through the thickness to our sensor locations.
Okay.
Fantastic. I think we have one more question that's come in here. This is from Rita. She wants to know, we know there's lots of cameras aboard Perseverance. Will any of the images be in color?
That's a great question. I think there may be a color camera on board. I know that the images thus far have been in black and white, but I believe those are the lower resolution images, and we have not yet taken advantage of the full communication bandwidth yet, because I think the rover has yet to deploy its medium gain and high gain antennas. So I do believe we may get some color images.
Yeah, there's
Gerald,
actually
do you know?
there's actually a couple of color images that have already come down. One from one of the HAZ cams. Also, there's some color images, one from Mars Reconnaissance Orbiter showing the spacecraft descending on the parachute, and another one that was taken from the sky crane looking down on the rover itself as it was being lowered on the cable.
And I think, Gerald, you may be
see
looking at the
if
Mars. Yes, these images
Yeah,
are available on the Mars 2020 multimedia page.
right.
Mhm.
So this is the spacecraft on the parachute here descending. This was taken by Mars Reconnaissance Orbiter as the spacecraft was descending, and this is probably after the heat shield was ejected. And then I know there's another image here somewhere. Hang on here while I try to find it. Because there's been several things have come down here. Maybe take another question while I find this other image here. I know there's another one that just came down. It's
We have another question from Bridget, wanting to know what data would be you'd be most excited about.
I'm a bit biased, and so I'm excited about receiving the full Medley 2 data set. But I'm also just excited to view all of the images, because I think it's pretty cool to see photos of another planet, especially if they're in color. But if I were to pick one, I would say the Medley 2 dataset, because that'll allow us to learn more about the EDL environment and improve our designs for the next Mars missions.
That's fantastic.
Mm-hmm. It was 6 years of work came down to 7 minutes of terror yesterday, and I'm just still on an emotional roller coaster from the successful landing.
We have a question from Christine. Is the rover capable of performing maintenance on itself, if necessary?
Okay. So the rover has more technology than any other rover in the past, and humans here on Earth, we have to sleep, right? And I know that the mission operations team at JPL, they have their crew there who is monitoring and sending commands to the rover. But I believe there will be certain points in time there on Mars where the rover have to decide and make certain decisions for itself. For example, once it gets its wheels going and starts exploring the surface, then if it sees an obstacle, then it has the ability to make a decision and decide the best path to get from point A to point B, such that yeah, it kind of diverts itself away from any obstacles. So this rover is more capable than the previous rovers.
Fantastic. Well, we are at the top of the hour. The journey does not end here. Perseverance is just getting started. In the link on both Facebook and YouTube, you can find downloadable materials and activities and posters, patches, etc. So please enjoy those. And thank you so much, Jose and Gerald, for joining us. We've learned so much from you. And once again, congratulations on the success of your mission.
Thank you, and you're very welcome. We had a great time.
Yeah, here's one of the first color images. This is showing one of the wheels on the ground. This was taken by one of the HAZ cams. So that imagery is now coming down. You can go to the Mars 2020 media site and see all these images as they come down.
Fantastic. Well, once again, thank you all for joining us. And for our guests who are watching with us, thank you. And by all means, it's not too late to support Chabot in our efforts to continue STEM education during our closure. You can use any of the donate buttons from Facebook or YouTube. And we'll be signing off now. So until the next one.